the special term linear increase. We call congestion avoidance. Why we call congestion avoidance? Something like right now, you think about this scenario. You climb a mountain. All right, climb a mountain. And if you have a hill over there, you climb a mountain, maybe right now it's high enough. And you don't want to get dropped. So actually, you try to trigger a new mode. You want to, something like you want to feel a small step is okay to reach the high enough position. So high enough, so you use a new way, we use linear increase. That says right now you use a conservative manner. So you try to test high enough and high enough. So this is called congestion avoidance. All right, so that's why we have congestion avoidance. But right now, we already know we have the complete version of congestion control for TCP. All right, so what that means, we have a slow start, right? And actually, we have a fast recovery. Previously, I think you understand what that means, fast recovery. 3 duplicate X, and then we can have the fast recovery. And before this page, we already have congestion avoidance. All right, so up to now, we have these. All right, so if we have these, data check all the details for the final state machine about TCP congestion control. Well, this is slow start, so initialization here. Initialization here. So how to set? We set congestion window to 1 MSS. So this is the initial value for CWND. And as for threshold, SS ratio, this is the default setting. So we set it to 64 KB, 64 KB. So we have the value here, KB, and how about the size for MSS? Actually, in terms of beta 12. All right, so that's why I asked you to treat MSS as a unit. And next one, we have a variable. Right now, duplicate X counter, set it to 0 because no, so of course we set it to 0. Well, this is initialization. And if we find a duplicate X, then we use double plus. That says increase the counter, duplicate X count. All right, so if we have a new duplicate X, of course, we increase this counter. Well, how about timeout? If we have a timeout, previously we already know for SS flash, we set it to half of the congestion window. So I think you understand this. And also, we have the reset. All right, reset congestion window to 1. And of course, for the counter, we need to set it to 0. So about the timeout, I think you understand the current operations. All right. Well, however, if we have a new duplicate, new X, and then if new X, you can have the increase of a congestion window by 1 MSS. Previously, we didn't know it's 1, but right now we need to take the unit into account. So that's why we have MSS. MSS, in fact, it's 1 MSS. So I think you treat MS as unit, and then it will be easier to link the previous concept to the current distribution. And because of a new add, so no duplicate add, so we need to reset the counter, right? All right, up now everything's okay. And the next one here, congestion window greater than or equal to SS range. And then we need to change. Actually, no altering, but we need to change the step from slow start to congestion avoidance because we need to leave the current operation of exponential fast to linear way to increase the congestion window, CWND. All right, so if we have this way, then we change to congestion avoidance. For congestion avoidance, we have the linear increase. Linear. So how to have a linear? This is a way to have a linear. All right, about the linear, what to do? In fact, if we have one X, we increase one MSS. But right now, because if we have, for example, we have the current CWND. So CWND plus this one, actually it's 1 SS. If we have an in the slow start, we should increase 1. However, we have this. Here, congestion window, we have the unit. For example, we have 64. For example, 64 kb. But MSS, if I use a ratio here, then it serves as a number, right? Actually, we have the size here to allow you to increase if you want to have the exponential fast. However, we don't want to have the exponential fast to reach there. We need to use linear. So that's why something like we have the number, using the number in terms of MSS. So for example, we have 8. Increase to that one. If we have 8, then you don't have 1 MSS. You use this one over 8. And once an add, then increase a bit and increase a bit. So this is a way to allow you to have the linear trend. So I didn't know this way, and so that this way, well, that you have the linear way to increase the congestion window. All right, so this is the reason why we don't want to have 1 MS simply, because 1, it is an exponential fast. And right now, try to use this way to share. Use this way to share 1 MSS for each egg. All right, this is the new egg. We use this way to increase the congestion window, and it will follow the linear trend. And of course, for duplicate egg counter, we set it to 0 for sure. All right, this is the first one. Well, up to now, is it okay? If it is okay, then let me erase some of the description here. Is it okay? Or maybe if you want to look at this, you can check the video. And next one, we have this. Duplicate egg, yes. All right. And if we have a duplicate egg, then if we want to reach this one, sorry, timeout. So timeout here, the same. All right. So for timeout, I think I skip it. Right now, let's focus on this. Yes, right now we have 3 duplicate eggs, so it's 3. So we have a threshold to a half of the window. That's correct. And also we have this one, congestion window. Because of 3 duplicate eggs, so this time we have the spatial value. plus 3. You can look up the task force. The task force allow you to let you know because of fast recovery. So we have 3 duplicate add. Because of that value 3 duplicate add, we also depth the window to include that 3. So that's why current access plus 3 to allow the fast recovery to speed up. All right, so this is a special treatment. This one not the same as the previous description. So that's why I have many circles here to draw your attention. This one different from the previous operation. All right, so if so, then we will have the fast discovery. Within fast recovery, possibly we may have 3 duplicate again. So, sorry, here, 3 duplicate again. So this one the same from slow start. All right, and actually we have fast recovery. And fast recovery, if we have a duplicate add again here because of fast recovery, so we don't want to throttle the CWND, so we increase it directly. So add it again. Why? Because within the mode of fast recovery, we want to have the special treatment. So we don't want to throttle CWND. So this time we increase it, and so they will try to finish all the possible recovery. All right, so this is a summary of TCP congestion control. Maybe some of different operation added to the summary, different from the previous discussion, but I think this is the final version. All right, so this is the final version of congestion control. It doesn't mean you need to follow the previous description simply. Actually, if we have some other changes here, you need to follow the current changes for the summary. In particular, we have class 3. 我这边就用中文特别讲一下，前面也许有些地方没有提到，但是这里特别提到加3。这个加3是跟前面所没有讲到的，这个是额外不一样的地方，所以有一个算 congestion window 的那个东西，其实要考虑到加3是这个理由。那这个理由是因为duplicate act 那个3，那再补那个3的值给它，而因此有额外的加3。其他的我想我都讲清楚了，因为这一个图很重要，所以我停下来。 不是要停下来，我改变用中文说给各位听。现在这边英文全部你都不知道什么意思。我想你了解，讲中文它没办法把它变成是正确的英文。Alright, so up to now I already know these, and the very special change here, class 3. So this one I think you should notice. As for the others, I think you can refer to the previous description so they can understand, oh, because we put them together, that's all. Okay, so up to now, everything's okay. So maybe let me clear so that we have the proper subtitles.